Hello everyone, now we are going to start with group 1 elements. So their properties we have to discuss. So I had written on the board electronic configuration of all the elements. So first is number of valence electrons. So number of valence electrons in each particular element you can see starting from lithium up till francium. They have one electron in their outermost shell. So first of all, number of valence electrons, they are equal to 1. Then next is valency. Valency depends entirely on the number of valence electrons and the nearest noble gas. So nearest noble gas to each and every one, with respect to lithium it is helium, with respect to sodium it is neon, with respect to potassium it is argon, and so on. So difference is only of 1, so valency is also 1. Now as these elements they have valency of 1, they easily lose their 1 electron and they get converted into unipositive ions, or we can say into monopositive ions. Uni means having one positive charge, like lithium on losing 1 electron it gets converted to lithium 1 positive. So it is the particular positive charge which they acquire after losing 1 electron. After that is their metallic character. Now this loss of electron, earlier we had discussed that elements which lose the electron they show the metallic character or they show the basic character. So all these particular elements of the group 1 they are metallic in nature or they exist as basic in nature. Reason is they always lose their electrons. So out of these elements, if we look at the elements starting from lithium to francium, the highest metallic element will be francium, because loss of electron from francium is very much easy. Why it is very much easy? Because francium is having largest atomic size, and if size is large, naturally the loss of electron is very easy because forces of attraction they get reduced. So francium is highest metallic element. Cesium can also be regarded as highest metallic element because francium generally it is radioactive in nature. So cesium, francium, all these are very much highest metallic elements from the entire periodic table elements. After that is their reducing nature. Reducing nature means they help in reduction. So elements or substances which help in reduction and itself which get oxidized, they are known as reducing agents or reducing substances. So all these elements they are very much strong reducing agents. Why? Because itself they are getting oxidized, itself they are losing their electrons. So the elements they could be acting as strong reducing agent. Next is their melting points. So melting points are quite low. Then these elements they are also very much highly reactive. Why they are very much highly reactive? Because they consist of only 1 valence electrons and that can easily be lost. So if loss of electron is there, naturally their reactivity is also very much high. So due to that very reason, the elements like potassium, sodium, they are kept immersed in kerosene oil. Why? Because kerosene is an inert solvent and it does not allow such elements like potassium, sodium to react in the presence of air. After that, reactivity with the acids. So all these elements they form their respective salts. Like sodium, when reacts with hydrochloric acid it forms sodium chloride, along with there is evolution of this particular hydrogen gas. Similarly potassium also it reacts with hydrochloric acid and leads to the formation of respective potassium chloride and hydrogen gas is evolved. So this is with respect to these very particular elements. Okay, now the next one is group 2 elements. They are commonly known as alkaline earth metals. Why they are known as alkaline earth metals? The reason is their oxides they occur in the earth crust, and moreover the hydroxides of all these elements they are not very strong bases, they are weak bases or weak alkalis which are water soluble. Hence they are known as alkaline earth metals. Now here You can see here again speciality among these elements that they consist of 2 electrons in their valence shell. So valence electrons in case of group 2 elements or alkaline earth metals, it is 2. Then valency of all the elements, it is 2. Then their occurrence, they do not occur in the free state, they always occur in the combined state. Then next one, their metallic character. So metallic character, we know as we move down the group, the metallic character increases. So metallic, out of all these elements, the largest one is barium, because radium is a radioactive substance or radioactive element. So hence radium is not included in that category, although it's a metal, but barium is considered the strongest metallic element of the group 2 elements. Now question generally arises, compare sodium and magnesium with respect to metallic character. So we know sodium and magnesium, out of these 2 elements, which one is having more size? Sodium. So more the size, more is the metallic character. Less is the size, more is the non-metallic character. This thing you have to keep in mind. Larger the size, larger is the metallic character, or highest or greater is the metallic character. On the other hand, if smaller size of the element is there, then non-metallic character is more. Not metallic character, non-metallic character. So here sodium is more metallic than magnesium. Reason is it is having more or higher atomic size. Now this one was regarding this one metallic character. Afterwards atomic size also it varies as we move down the group, the atomic size increases. Next, reaction with water. All these elements, as I said earlier, they are forming the hydroxides, but these hydroxides are not very strong. So magnesium, when reacts with water, it forms magnesium hydroxide, along with evolution of hydrogen gases there, because this is in accordance with the reactivity series that you had studied in your previous class. It is very simple. The higher reactive element, it displaces the hydrogen from its respective compound, either it's water or it's acid or something else. So magnesium, more reactive than hydrogen, displaces the hydrogen and itself it forms the oxide, hydroxide, and hydrogen gas is evolved. Similarly, other metals like calcium, when it reacts with water, so it forms calcium hydroxide, along with hydrogen is given out. But water here, it is not very cold, it is hot water having higher temperature. Similarly, other metals, they also do react, but their reactivity with water decreases because size increases and displacement of hydrogen also, it becomes difficult. After that, with air, they will form the respective oxides. Like magnesium, when it burns in the presence of air, it forms the magnesium oxide, which emits a dazzling white light, along with heat is produced. After that, they are also very strong reducing agents. These elements, they are very much strong reducing agents. Why? Because they lose their electrons very easily and they form dye-positive ions. Dye-positive ions means these all are having valency of 2. So magnesium, whenever it combines with other elements, or we can talk about any other element also, suppose we talk about calcium. So calcium, we know it is having atomic number 20. So calcium, whenever it combines, it gets converted into Ca2 positive, calcium 2 positive ion. So this is due to loss of electrons. Now calcium, whenever it loses 2 electrons, it becomes dye-positive in nature, and due to this very reason, these elements, they are also reducing agents, but they are not very strong reducing agents than group 1 elements. So whenever question comes, compare sodium and magnesium, which one is more particularly reducing agent in nature, strong reducing agent? So the answer is sodium. And if calcium and potassium, or calcium, potassium and magnesium, So first of all, the stronger one is potassium, followed by calcium, and at the last is magnesium. Clear? Next, these elements, they also impart the specific color to the flame. So with respect to each and every particular element, the color is different. Like for calcium, it is brick red. Whenever calcium is kept or burnt in air using platinum wire, then strontium, it shows the crimson color. Barium, apple green. Radium, only crimson or brick red color is there. Then these elements, they also have higher, not very higher, melting and boiling points, but their melting and boiling points are higher than group 1 elements. The reason is they have small size than group 1 elements, and their force of attraction, that is their nuclear charge, is also stronger than group 1 elements. So loss of the structure, that becomes difficult, but not very difficult. But if comparison is there, that which one is more stronger, so your answer should be group 2 elements, that is alkaline earth metals. They don't have that many strength. Okay, now the next one is group 17 elements. Group 17 elements, they are known as halogens. The reason is all these, they are salt forming in nature. So halo means salt and gen means former or producer. So first of all, their electronic configuration is in front of you. So all these have 7 electrons in their valence shell, starting from fluorine and up till last astatine. So first of all, number of valence electrons, that is 7. Now valency, it is simple trick, nearest noble gas, or you can see if electrons are more than 4 in the valence shell, you can deduct it from 8, so valency is 1. So in all these you can calculate. Now after that, these are always existing as non-metals. Non-metals, why? Because they do not lose their electrons, they always gain the electrons in order to get stable, hence they are non-metallic in nature. And as we move down the group, the non-metallic character, that decreases. So fluorine is the strongest non-metal, and iodine is the weakest non-metal of group 17 elements, because astatine is again the radioactive element here. Then atomic size also, it decreases. At the top element, it is having smallest size, the lower one, it is having the largest size. So fluorine is having smallest size, followed by chlorine, followed by bromine, then is iodine, and then is astatine. So always question will come like, arrange the following elements in the order of their increasing or decreasing atomic size. Like question will be, for example, fluorine, arrange fluorine, magnesium and nitrogen. So how you will see? First of all, you need to check their number of shells, then number of valence electrons, and after that you have to arrange. Like here fluorine and nitrogen, we know they both have 2 shells each, and magnesium, it is having 3 shells. So number of shells, if they increase, it means the period number also is more. So magnesium is largest, then followed by nitrogen, because nitrogen, it is having less number of valence electrons. Here period number is same in both the cases, and the smallest one is fluorine. So that way you have to compare all the factors. You need to check how many number of valence electrons are there, how many number of shells are there, whether it is metallic or it is non-metallic. That you will see from the number of valence electrons, because if valency is more, it means that particular element is metal, or it could be non-metal also, depending upon number of shells. So all those factors you have to check. Okay, now this one we are discussing that these are non-metals in general and their atomic size, that also it decreases or it increases. So atomic size increases because number of shells they are increasing down the group. After that, all these elements they form uni-negative ion. Uni-negative ion means they always gain the electron, and on gaining the electrons they acquire the negative charge, negative of 1 magnitude. So F negative, Cl negative, Br negative, I negative, all these are ions which group 17 elements they are forming. Now the last one is group 18 elements. Group 18 elements also known as zero group. Why zero group? Because this particular group was discovered very late from the rest of the elements, hence it is known as zero group, because nobody knows earlier that such 6 gases they also had the existence in the nature. Now these group elements they are also known as inert gases. Why inert gases? Because you can see here in each particular case the number of valence electrons that is complete, their configuration is stable. So due to that very reason they were earlier known as non-reactive gases, but some compounds of krypton, xenon they have been synthesized, they have been prepared. Due to that very reason this name was changed to noble gases. Noble gases means having very low reactivity. Now these gases they are neither the supporter of combustion nor do they burn. That's why helium is used in weather balloons. Neon, argon and other gases they are having variety of applications. Okay, this was regarding chapter number 5, periodic table. So in this chapter many type of questions could be there, like comparison of atomic size, metallic character, non-metallic character, how the number of electrons they do vary, what is the magnitude of nuclear charge. So you have to read the chapter very thoroughly, all the points, all the videos you have to watch, and then I think so that it will be very cakewalk for you. Thank you all for your valuable time.